this video, we will discuss the application of the Internet of Things in asset performance management. Asset performance management (APM) is one of the industrial IoT's most prevalent use cases. The power sector in Asia suffers from high levels of insufficiency and unreliability due to poor maintenance coupled with equipment ages. The current status of operation and maintenance, as known as O&M, in the power industry can be summarized in these observations. The average age of asset is 40 plus years. The assets are expensive, large and difficult to replace. Historical data about asset is not centralized. Disparate systems. Many experts are reaching retirement age and they are not being replaced and trained. As monolithic utilities deregulated, privatized or converted to autonomous entities, operations and maintenance budgets are being cut. Given this state, the impact of IoT on APM can be significant. Without IoT, an organization would have to be reactive or preventive maintenance. With IoT, instead of spending the operation and maintenance budget to perform scheduled maintenance at fixed intervals on all units, the focus can now be on where it is needed. The most based on condition, predicted time to failure and risk of failure. Operations and maintenance strategies are enabled by IoT, such as condition-based maintenance, in which patterns in sensor data are identified to plan maintenance of this asset. Predictive maintenance, in which trends in sensor data are identified to predict time to failure, which is impending failure and problems are identified, which guides predictive maintenance. Risk-based maintenance, in which the decisions about maintenance of an asset is also based on optimizing the use of the maintenance of resources across all assets. This approach uses the risk of failure as the metric to allocate maintenance resources. The risk here means the product of the probability of failure and the economic consequences of failure. A transition from reactive maintenance to IoT-enabled proactive maintenance have the following advantages: improved reliability and availability of the assets, reduce the cost of maintenance, significant reduction or elimination of unplanned downtime, hence no expensive emergency repairs and lost productivity, replacement of scheduled preventive maintenance with predictive maintenance and risk-based maintenance, thereby increasing availability and reducing cost, lowering inventory of spare parts for emergency repairs, and higher productivity and safety of repair crews due to identification of the sources of failure. Thus far, the focus has been on generation asset. The APM applies to all assets, including transmission and distribution assets like transformers, switch gears, capacitors, insulators, conductors, and others. These assets suffer from electrical breakdowns due to material degradation and mechanical deformations. The dielectric and thermal material degradation are primarily due to aging, over voltages, and thermal overheating. Mechanical deformations are caused by short-circuiting faults. IoT sensors can provide data about health of these assets to improve grid reliability and reduce the cost of repairs. So with that, we have concluded that the application of IoT comes with innumerable advantages when it comes to the asset management system in power sector.